Multiply and divide algebraic fractions with Adam Maths Tutor. The method for multiplying and dividing algebraic fractions is exactly the same as it is with numeric fractions. If you're multiplying, just multiply the numerators together and the denominators together. Once written as a single fraction, we can cancel common factors from the numerator and the denominator, just like shown in my previous video on simplifying algebraic fractions. So start off by multiplying the numerators together, which will give me 24st squared. Next, multiply the denominators. 2 lots of 6t is 12t. Now we can simplify by looking for common factors between 24 and 12. Both are divisible by 12. 24 divided by 12 is 2, and 12 divided by 12 is 1. We can also find common factors between the algebraic expressions. We have s in the numerator but not in the denominator, so s will just stay the same. Lastly, we have t squared at the top, t at the bottom. Both will divide by t, leaving us with t at the top. Tidying this up, as we don't have to write this over 1, so it would be 2st. The only difference with dividing algebraic fractions is remembering to use keep, change, flip. So we keep the first fraction the same, change the operation to a multiplication, and flip the second fraction upside down. Multiplying the numerators, 3 times 28 is 84, x cubed y to the power of 5. Multiplying the numerators, 4, x to the power of 5 times x is x to the power of 6, and y times y will give us y squared. 84 and 4 are both divisible by 4. It goes in 21 times and once. X cubed and x to the power of 6 can both be divided by x to the power of 3, leaving you with nothing at the top and x to the power of 3 at the bottom. And lastly, y to the power of 5 divided by y to the power of 2 will leave us with y to the power of 3 at the top. If you're finding the simplifying part of these at the end quite difficult, then you should really go back and watch my video on that. Lastly, we can tidy up our answer by writing down 21y cubed over x cubed. The intermediate questions have an increase in difficulty with some operations within the individual fractions. We'll still start in the same way by multiplying numerators and denominators. Just bear in mind that we're multiplying 3a by 6a plus b. There's 2 separate terms here, so the use of a bracket would be useful. So 3a multiplied by 6a is 18a squared, and then we're adding that on to 3a times b, which is 3ab. Likewise, we have a similar issue at the bottom with b plus 1. So put this in a bracket, and we need to start by doing 12 times b, which is 12b, and then we're adding that on to 12 times 1, which is 12. Again, linking back to my video on simplifying, where we had single fractions involving separate terms, we'd want to factorize the numerator and denominator to find common factors between the two. So factorizing the numerator, we'll be able to take a factor of 3 outside the bracket. Both of these terms also involve a, so we'll be able to take a outside the single bracket. And on the inside, 3a times 6a will give me 18a squared, and 3a times b will give me 3ab. Repeat the process with the denominator. 12 and 12 both have a factor of 12, leaving us with b plus 1 inside the bracket. Now we can focus on the factors which are outside of the single brackets and simplify these parts. Notice how we have a factor of 3 at the top and a factor of 12 at the bottom. Both of these are divisible by 3. 3's go into 3 once, 3's go into 12 4 times. Nothing else can be simplified, so everything remains the same, meaning this can be tidied up to give us a bracket 6a plus b at the top and 4 bracket b plus 1 at the bottom. There's no need to expand these brackets, as that would be no more simplified than what we already have. On to the next, remembering to use keep, change, flip. 2c plus 1 over 3d squared multiplied by 18 over cd gives, remembering to use a bracket when you have more than one term. 18 times 2c is 36c, and 18 times 1 is 18. At the bottom, we have 3c, and then d squared times d is d cubed. Now for factorizing, which we'll only be able to do with the numerator, both 36 and 18 have a factor of 18, leaving us with 2c plus 1 inside the bracket. The denominator cannot be factorised, so we're left with 3cd cubed. 18 and 3 both divisible by 3, leaving us with 6 and 1. There's no other common factors, which means 2c plus 1 at the top and cd cubed at the bottom, leaving us with a final answer of 6 bracket 2c plus 1 over cd cubed. The advanced and most tricky types of questions on this topic often involve some quadratic expressions. It would be too long-winded to start by multiplying numerators and denominators and ending up with 3 terms in a bracket which need to be multiplied by another 3 terms in a bracket. Plus, this will also produce a quartic which has x to the power of 4, and we're not in a position to be able to factorise these. Instead, you factorise at the beginning so that we can find common factors between the expressions. We did factorising some quadratics in my last video, but really if you find that tricky you should go back and watch the actual video on factorising quadratics. So for the first quadratic we have here, we're looking for numbers that multiply to give us -4 and add to give us -3. That would be x minus 4 and x plus 1. For the denominator, numbers multiplying to make 6 and adding to make 5, x plus 3 and x plus 2. This one would be x plus 2 bracket x plus 2, and this one at the bottom cannot be factorised, so it remains as x minus 4. Notice that previously when we multiplied to make a single fraction, at the end we were looking for common factors between the numerator and the denominator and cancelling. Notice here how we have x minus 4 at the top of this fraction and x minus 4 at the bottom of this fraction. So when we multiply those together, we'll be able to cancel one from the top and one from the bottom, meaning we can cancel these 2 factors at the top and the bottom. We also have an x plus 2 here at the top and an x plus 2 here at the bottom, so we can repeat the process for these as well and cancel them. And once you run out of ones that you can cancel from top and bottom, we just write those as a single fraction with the factors that are left. So as the numerator, we would just have x plus 1 bracket x plus 2, and the denominator we just have x plus 3 left, so x plus 3 at the bottom. Lastly, for the trickiest type of question, you might often end up with some expressions which are a little bit harder to factorise, but this is also a division, so we're going to need to remember to use keep, change, flip. The first fraction remains the same. I'm going to factorise at the same time. Here we have difference of 2 squares, t plus 3 and t minus 3. This quadratic will factorise to t plus 2, bracket t plus 1. This one will factorise to t plus 3, bracket t plus 3. Just remember I'm flipping this fraction, that's quite a few steps to do in one go, which is why I've written it onto the bottom as opposed to the top. And the denominator, which has now been flipped to the numerator, would be t plus 1, bracket t plus 7. We have common factors of t plus 3 at the top and bottom, so cancel. We also have common factors of t plus 1 at top and bottom, and there's no more common factors, so see what we're left with as the numerator, t minus 3 and t plus 7, over t plus 2 and t plus 3. Before you go, have a little look at this solution that I've produced for a question similar to an intermediate one. See if you can spot or correct any of the mistakes and write them down in the comments below.
Thanks for watching. If you found that video useful, don't forget to hit the like button and leave a comment. If you're struggling with maths or finding topics difficult, you can subscribe and turn on notifications to receive regular updates about new video tutorials. Don't forget to visit my website adamonlinetutoring.com for a full searchable list of all topics with exams, questions and solutions. You can also visit me on social media using the handle @AdamMathsTutor on Instagram, TikTok, Facebook and Twitter. All links in the description below.